Module 12, problem set 2. Here in question 1, we're asked to come up with 3 contributors to the resonance hybrid for thiocyanate. You have to recall what thiocyanate is. This is SCN, carries a -1 charge. So again, molecular ion. Okay, let's begin by identifying how many valence electrons we're going to have to work with. So we have a group 6, a group 4 for 10, a group 5 for 15, one more to impart that -1 charge. We have 16 valence electrons. Here we will go with the least electronegative of the elements to be our central atom. That would be carbon. I'll attach the adjacent elements. I will give everything an octet that needs an octet. And again here, that is everything. Give everything an octet that needs an octet, and I have used too many valence electrons by 4, so here I have utilized 20. I'll take a lone pair away, a lone pair away. So here I have selected to remove a lone pair from each of the adjacent atoms, and I'll introduce double bonds. I'm now satisfying the octet rule for all atoms involved, and I've used 16 valence electrons. I would indicate that that carries a -1 charge. Let's now check the formal charges here. So we recognize we have 0 formal charge on that carbon. Sulfur in group 6, so that is 6 minus the sum of 4 plus 2. That is also 0. And we have a -1 formal charge on the nitrogen. Okay, we would expect this to be perhaps the greatest contributor to the resonance hybrid because I have the -1 formal charge on the most electronegative element. But recognize there are other contributors, minor as they may be, and we were asked to provide 3 contributors. So here is one. What are the other ways I could have done this? Well, recognize I could have had a sulfur singly bonded, a carbon then triply bonded, carries a -1 charge, or I could have done that just the opposite, a sulfur that is triply bonded, a nitrogen that is singly bonded, and in the assessment of which of these would be the greatest contributor, again, it's going to come down to those formal charges. In all of these cases, that carbon is 0. But in identifying what the formal charge is now on this particular nitrogen, well, it's in group 5. We had 5 minus the sum of 2 and 3. That is 0. Here, the sulfur carries a -1 charge. And down here, the sulfur being in group 6, I would have 6 minus the sum of 2 and 3. It carries a +1 charge. Nitrogen in group 5, so 5 minus the sum of 6 and 1. It carries a -2 charge. So the further my formal charges are from 0, it's usually an indication of less and less stability, less contribution to the resonance hybrid. So this is certainly my greatest contributor, but we have represented 3 contributors overall. Okay, let's do question 2. And in question 2, we are asked to come up with 3 contributors to the resonance hybrid for this molecule, SNF3. This is thiazyl trifluoride. Okay, so how many valence electrons do we have to work with here? Okay, so we got a group 6, a group 5, 3 that are from group 7. We do that necessary arithmetic. We're going to come up with 32 valence electrons. All right, fluorine being the most electronegative element on the periodic table, we would not expect it to be our central atom. Sulfur, less electronegative than nitrogen. So let's place that sulfur in the middle as our central atom. Let's attach the adjacent elements. And let's give everything an octet that needs an octet. And here that is everything. So all of the adjacent elements now have their octet, as does the sulfur in the middle. I've got 8 times 4 for 32, so I have used the requisite number of valence electrons. I could consider this a contributor to the resonance hybrid, but to what extent does it contribute? Let's assess the formal charges. Each of these fluorines would be 0. Sulfur in group 6, so it's 6 minus the sum of 0 and 4. As it stands right now, that sulfur has a +2 oxidation state. Before even doing the math, I recognize that nitrogen must be -2, so that when everything sums together, I get 0 for the neutral molecule. Indeed, when I take 5 and I subtract from it the sum of 6 and 1, indeed I get -2. So this is a contributor, but certainly a minor contributor with a +2 and -2 formal charges. Is there something I could have done to reduce those formal charges? Indeed, I could keep the fluorines as they are. That would make sense because they already had the 0 formal charge. Let's now shift a lone pair of electrons in my diagram down to introduce a double bond to that nitrogen. So I violated the octet rule on the sulfur, but that is okay. Recall, sulfur is in period 3. It can have an expanded octet. And in doing so, notice what has happened to the formal charges. This has now been reduced by 1 to be +1. This has increased by 1 to be -1. And you may recognize I could do that same sort of operation again. There's my fluorine, my fluorine, my fluorine. I made a triple bond to that nitrogen. Notice I now have formal charges 0, 0, 0. This is now 0, as is this. So I have reduced the formal charges. I would expect certainly the greatest contributor to the resonance hybrid to be this configuration.